Okay. Hi, everyone. Good afternoon. Who likes logging? It's not a trick question, don't worry. So oftentimes when we do logging, we want to log all the things, especially when we have something ephemeral like Docker containers or Kubernetes, or when we have more than one single instance. So if you have the good old monolith, SSH and tail was kind of working. But that's kind of a thing from the past, so it's not really working anymore. So you need something else. And then people often say like, well, whatever we do, this is fine, and this works for some time. Until you run into something like this, like you have this humongous log file, and you're like the little submarine looking for something. And then at some point you figure out this is no longer fine, and this is not where you want to go. So we kind of want to avoid the bottom half where everything is on fire and everything is terrible. We don't want to get there. So let's see where else we can go. So I work for Elastic, the company behind Elasticsearch, Kibana, Beats, Logstash. We do quite a bit about logging. Probably some of you have heard of the Elk stack, or is anybody using our stack already? Out of curiosity, okay, a few. So Elasticsearch kind of stores the data. Logstash is the thing to get the data, parse it, enrich it, store it there, and Kibana to visualize. What do I mean when I say parse? Probably something like I have a log line and I want to extract like a timestamp at the log level to have that in a structured format. What do I mean when I say enrich? I might have something like an IP address and I want to have the geolocation, for example. Or I might have the Docker ID and I want to get the labels for the Docker container. Or in Kubernetes, I might have an ID and I want to break that down on a namespace or on the pod or the host where this is running. So I can kind of like enrich and add information where it's needed. That's kind of the idea. And at some point, we added some other component called beats to the stack. And then we tried this thing where we call it the elk bee or belk, which could also look something like D. You can see it's an elk, it's a bee. It's a combination of the stuff. But we're always about scaling. And this is not very scalable in terms of marketing. Because what happens if we add another product, let's say APM or tracing that we've added, we would need to add another letter and make up another animal. And it's not getting easier finding new animals or making up new animals. So we kind of got rid of that thing. Like sometimes we have stickers of those still, but now we just try to call it the Elastic Stack because that's kind of scalable in terms of marketing. Because whatever other product we put in there, maybe we have to add some more colored blocks in the corner there. But otherwise, it stays the same. That's why we call it Elasticsearch. But if you say elk, we'll still know that. So this is what you've got, basically. You have the beat, which is like a lightweight agent or shipper written in Go. So you have native binaries that forward stuff. For example, we have file beat for logs. We have other beats for other stuff like metrics, network packets, heartbeat for health checks, etc. But file beat is the thing to forward logs. And then you can either send that to Logstash to do the parsing and enrichment, or you can forward to Elasticsearch directly. There you store it, and then Kibana can visualize all of that. So let's do a quick demo. And while I explain the demo, let me start. I'm running this on Docker Compose because it's lightweight and simple enough to run on my laptop. This will take 2 or 3 minutes to start up. So we'll let this run here in the background. It's starting up. I'll use a very, very simple application. I always call it the hello world of logging. I'll use Java. If you don't program Java or don't care for Java, it doesn't matter. These are the technologies I'm putting together here. But if you use any other language or any other tool set, even in the PHP world, you have proper loggers by now. So it doesn't really matter where you're coming from. You just want to have a proper logger to log stuff from your application or your infrastructure and collect those. Two things we don't want to do or we want to have. The first thing is we want to have a proper logger. Like we don't do system out or println or whatever, because we want to have log levels and a bit more structure maybe around our stuff. The other thing, especially when you want to centralize, that we don't want to have is too much coupling. So what I don't want to have is I don't want to have to redeploy my application, for example, when I change something in my logging backend. So we don't want to have too much tight coupling between the two. And we'll get back to that once or twice, because with some solutions, you will have more coupling than you might want to have. And we don't want to go there. So the first thing is, let's do the parsing. Parsing is kind of like the good old approach. Like you have the classical log lines, you will break them apart, and you want to work with your logs for that. And for that, I'm have a very simple program. So my demo is starting up in the background. It's probably still coming up, but we can quickly look at what we're logging. So this is really just hello world. We have a logging class here. I have a loop going from 1 to 20, and it's creating a trace message for every time this is running. And I basically log out the iteration, and then I have a so-called fake session, which is just a random number, 0 to 99. And then, depending on if the iteration here of my loop can be divided by 15, I will have a runtime exception, divided by 5, a warn, by 3, info, and otherwise a debug. So one of these here will happen. So what is the pattern that I'm logging here? Has anybody done job interviews recently? That's the FizzBuzz thing, which comes up in job interviews every now and then, where you need to generate something and it says fizz or buzz, depending on how a number can be divided. So this is super simple. Even if you have never seen Java, you probably see what is going on here. The interesting part is we have a loop here, then we have the trace message, and then we have one of these others here. How many log messages will this spit out? Any guesses? Who is for 19? Who is for 20? Anybody for 38? Anybody for 40? Yeah, 40 ideally it is. So we have a loop 1 to 20 inclusive, so it will do 20 iterations. And then we will have 20 trace statements and 20 other which are one of these. So we will get 40 log messages in total ideally. And we write that out to a log file, which is this one here. So it looks something like this. You can see here we have our log messages, and we will get 20 events, and we'll take them, parse them, and try to centralize them. One thing, did anybody figure out what this one here is? That's an emoji, because nowadays everything needs to have emojis. This is just to demo that throughout the entire logging stack, we can work with emojis as well. And you could, for example, add your user experience in emojis. So here, basically, I have a user experience, and it's kind of a structured field where I add like an emoji for the user experience. And you will see later on what that is. So what we basically get is, let me quickly open up Kibana. Hopefully the stack started up correctly, because it's a demo and you never know. Let's see how this is working today. So no, I don't want to send statistics. And I hope this is this readable for everybody? Give it 1 second to load the right page. Okay, I think this is the maximum I can get you. If it's too small, please come closer. So the first thing you see, we've started our demo, it logged something, and we have 42 events. How many events were we expecting? 40. Anybody can already guess what has gone wrong? Because this is something you might end up or run into every now and then. So let's look at one of the log messages that we have in here. So this here is this was the log message that we've collected. So this is one log line here. And we have extracted, for example, the log level. You can see here we have trace. Let me add that to the column so we can see that more easily. And now, for example, you can see we have all the log levels, what we have collected here. The thing that is sticking out is those two here. They don't have anything. Generally, 42 would always be the right number. But in our case, we want to have 40. So this is weird, so let's see what is happening here. And looking at this one, what do we have here? Those who have worked with Java at any point in the past probably know what is going on here. This is part of a stack trace. So if I look at my log, and I scroll up here, you can see here, this is my error. This is throwing a runtime exception. This was the emoji that we had here, by the way. So in the log file, it's fine, and we'll see it in the stack as well. But you can see this is the first line, and then I have a stack trace which adds 2 more lines. And this is how I got from 40 messages to 42, because I have these 2 extra lines in the stack trace. If you centralize logs, is breaking up a stack trace very helpful? No. What do you think is easier? Not breaking up the stack trace in the first place, or recombining it in Elasticsearch afterwards? it's much easier not to break it up in the first place. I always compare it if you have meat and you put it through a grinder, then you want to put back the steak together. That's pretty much what you're trying to do if you break up the stack trace and try to recombine it afterwards. This will be much harder. So we don't want to break up this stack trace into multiple lines. Any guesses how we could avoid breaking up a stack trace here? Basically, you can see all the lines starting have a specific pattern. Here, this one. And this one doesn't have it. So we basically have a square bracket and then some date. And what we want to do now is, like in every good cooking show, I have kind of prepared this. Let's say this one here. This is the thing you want to add, basically. So what I'm doing here is I'm reading my log file. That's fine. But I need to add this multi-line pattern, because what FileBeat that is collecting that log file by default is doing is like every single line is its own event. And here, I'm basically telling it, well, some events have multiple lines. And basically, if a line starts with a square bracket, so it starts, and you need to escape the square bracket because this is a regular expression. Anything that follows after it is the continuation of the previous line. So anything that doesn't have a square bracket is the continuation of before and should be combined together. And this is how to tell that to FileBeat not to break it up. OK, so this is saved, and this will automatically refresh in the background. So what we can do is we have a couple of containers running here the entire stack, and this is very hard to read. But we have a Java application, and I just do a docker restart Java app. This will rerun my application. It will spit out its log events again. How many log events should we have now in total? Hopefully, let's see. So ideally, if I refresh that, we should probably have 82, because we had 42 from before. Now I fixed the multi-line problem, and now it should add another 40. And yeah, luckily, it's exactly 82. We got 40 here, and now all our events are correct. And now we could say, this is the error message here. If I open that one up, you can see, OK, it extracted these properties here, and it kept the original message here. So we didn't break up the stack trace, and it's OK. So this is what we wanted. We didn't break up the stack trace. That's the first thing we want to do. The other thing is, out of one log message, for example, we have this one here. We need to parse this. How do you do the parsing to actually extract stuff like the log level? For example, you can see here we've extracted the log level. We have extracted the method where this is running. So this is this one here. How do we break this one up? Probably with a regular expression. Who likes writing regular expressions? Yeah, I always say this is kind of the Stockholm syndrome, where you get so used to writing regular expressions that at some point you like it. Sometimes it's also job security. Yeah. So for those of you who like writing regular expressions, you can help me out now to write the right regular expression for this one. Because how do we get to that regular expression? Let's copy this one here. And there's one tool in here that makes your life a bit easier. So we have something called the grok debugger. Grok is basically named regular expressions. So we add that sample line here. This is the line that we have. Then we can define our grok pattern and simulate how to break this one up. And how do you know which grok patterns exist? Let me open the right documentation page here, or the right reference. These are the named, no, go away you. These are the grok patterns. So basically, rather than having to write this regular expression, you can reference this by using username to parse this. This is basically the idea of grok, named regular expressions. And luckily, I know that the one we want for the timestamp, like we have a full range of things to parse timestamps, is the timestamp ISO 8601. This is the grok pattern we want for our timestamp. So to parse this one here, those who like regular expressions, now is your time. How do we parse this one? Well, we start the line. Then we have a square bracket, but the square bracket needs to be escaped, so we start with an escaped square bracket. Then we have the grok pattern. Grok patterns are always like curly brace, percentage, curly brace. the name of the grok patterns, colon, and then the field into which we want to put this. So this one, for example, is a timestamp. If I simulate this now, you can see I've extracted that part. Now you could close the square bracket. That's also important. You need to close it. Then you could have a space. This is the one I want. Space basically eats any white space. So one or more spaces or tabs will be eaten up by that. And since I don't put that into a field space, this will just disappear and basically be eaten up. And after that, we have a log level. So I think that one is called log level, if I'm not mistaken. And I call this log level. Let's see. And you can see here, this is how I break this one out. You probably don't want to see me write the rest of this one here. So we have that in our configuration as well. So here we have grok match on the message field. This is the entire regular expression that we run here. And you can see this one is the right pattern to parse the stack trace, by the way. So this is not going to be so much fun and kind of repetitive. If you have lots of log files and you need to parse all of them, it's not going to be that much fun. So one way to make this a bit easy, we've recently added something to have a bit of more kind of like automation around this. And this is part of the tools that we call machine learning. If it's really machine learning, it's a different topic. But what you can basically do here is you can upload a file. So here I just upload a file, and let me head over to the right folder, this one here. I upload my log file. And this one basically looks at this, and it knows some patterns. For example, it knows when I see trace or debug somewhere, this is probably a field that is doing logging. And when you scroll further down here, this is the grok pattern it basically suggests. So it tries to guess a grok pattern. This won't be perfect, but this is kind of a good starting point. So you don't have to write the entire grok pattern yourself. You can see it got the timestamp right, it got the log level right. Afterwards, it got a bit fuzzy with the user and the session. It wasn't that good, but you can see it got like the log level correctly, and it extracted these other things. So this is generally a good starting point, and you can just use that to start parsing. And I think this is it pretty much for the parsing. So the good thing is you don't need to change anything in your application. The bad thing is you need to write regular expressions. You need to watch out for multi-line statements, which are tricky. And if you change the log format in your application, you also need to change the grok pattern in the log append or in logstash that is doing the parsing here, which you have some coupling then. So maybe you don't want to do that. Any other ideas how we could get to our logs in a better way? So one thing we could do is we could send it directly. So basically, we have a specific log appender that sends to logstash directly, so we don't write out to a file, because it's kind of stupid what we did. We wrote out to so our application had the log in a structured way. It wrote it out to a log file, only then we parsed it back. So our log appender has it structured, so it could send it directly to logstash. It could just insert that and be done with it. So that is basically it. So you don't have file bit here, you send to logstash directly. Elasticsearch stores it, and in Kibana you can visualize that. There is one downside to this one that I can show you as well. So if we had back to parse, we had 82 messages. If the parse index loads, give me a second. Parse here, and you can see this is when we started this. And just to make sure, I'll say the last 30 minutes so this doesn't time out. So we have 82 messages here. How many events do you expect in the send index? Ideally 80, right? Because we had 40 for the first time and 40 for the second time. Since we didn't have the multi-line statement problem, we should have 80. So let's see what we have in the send index. We only have 40. Why? When I started up my Java application, it came up before logstash was up, so it could never deliver the logs to logstash. And this is already kind of the biggest downside of this approach. If your network is down, or if your application cannot reach logstash, they will just go into the void, like basically dev null. Only the second time I ran my application, logstash was up, and it would reach Logstash to forward the logs. And especially when your network is not working or something is kind of like going badly, then you're interested in your logs. So this is the main downside here. Also, you have the downside of coupling, because now your log appender suddenly needs to know where is Logstash. And if you add more Logstash instances, you will need to reconfigure your Logstash output in the log appender. So you have a bit more coupling between your application and the logging backend. So maybe you don't want to do that. What else could you do to make your life easier? Because I'm lazy and this is a feature. You don't want to write a regular expression. So what you could do instead is you could write a structured log. Since Elasticsearch is storing JSON, if you log to JSON directly, basically the log or file beat can take the JSON file and forward it to Elasticsearch directly. So what we have with that one is, if I look at my log, if I would see my log, here I log to JSON directly, which is still kind of humanly readable, and you just forward that. How do we treat the stack trace? Any guesses what happens to the stack trace? Do I still need to watch out for the stack trace? No, that one is also escaped. Let me scroll to the right, because here it will stick out. You can see here, this is the one with the stack trace, and here we basically have \n for new line, \t for tab. This is our stack trace. So it's still a single line, so you don't have to care about multi-line statements either. And basically, I just tell FileBit, hey, here is a JSON file, parse it as JSON, and then just store it into Elasticsearch, and you're done. So if I look at the structure index, which contains or has that file, how many events? This one hopefully has 80. You can see the log level was extracted correctly, and here everything kind of works as you expect. So we have all the structured information, everything is there. So this one is good. You might have a slight overhead in JSON serialization, but writing out JSON is normally OK. So this is kind of like the better approach. If you need to write out logs, you can skip the parsing, and you can just forward your logs and pretty much be done with it. So this will make your life easier. Now, how does this tie into Docker? Let's see. Where do you put FileBeat? Ideally into a sidecar. So the sidecar watches some logs, and then you're done. So basically, you have your logs being written out to the Docker default JSON log, and then FileBeat running as a sidecar just tails all these logs and forwards them. We have some deployment scripts of how that looks like. Pretty much what we are doing here is auto-discover, and I just say like, hey, you're running in Docker, and pick those up, which just works because basically with Docker, you know where is the default Docker log going, and then you can pick that up. If I run it in a sidecar, I will need to mount that folder into the sidecar from the host so that it will actually pick up those logs correctly. The other thing is that you can add metadata. Metadata is basically if you mount the Docker socket into that sidecar, we can use the ID from the Docker log to actually look up against the socket what is the ID of that container, and then get all the metadata for that container, which will look something like this. So here, for example, you can see which project and which service, and we're running this with Docker Compose. We can pick all of that up and add that in the logs. So if I open that one here again, you can see, if I switch over to the container one, how many events do you expect from the containers? Many, because I didn't specify which container to monitor. And I'm running Elasticsearch, Logstash, FileBeat. They're all containerized, so I'm picking up all the containers here. But since we're getting the metadata, we can easily filter down on that. So for example, we can just say container, let's go for labels application, equals. And then fizzbus is the name of my container because I have the fizzbus application. So I've just added that Docker label. If you filter down on that, then you can see now we have 81. Why do we have 81 messages? If you scroll to the very first one, this one here, you can see that this one is an output of the logger itself. So this is just an info message from the logger itself that is being put out here. But otherwise, it did parse everything correctly, and we have all the events. And we have all the metadata here. For example, here under container, Let me open the JSON view, which makes this maybe a bit clearer. So here, under container, you see what is the image name, what is the ID of that container, all these other metadata. We also have something where I have here the Docker metadata, and then we have the host metadata, so we know where is this running, what operating system do you have if you need that. If you have, for example, if you run that on a cloud provider, we could add stuff like the region, the availability zone, the instance ID. We basically can just add all the metadata so you can filter as needed. So this one will make your life easier for filtering. We can skip that part. Basically, one other thing is, sometimes people say, like, this view is nice, but I still want something more like tailf. And we have added a new UI that is a bit like tailf. So this is called the Infra Logs UI, or just logs. If you look at it, I need to change what I want to monitor. So here I'm interested in the Docker logs. So I'll just say this is the Docker index. I can say which fields I want to have here. So for example, since I have a log level, I can customize that and say this has the log level. I want to extract that. And oops, you stick up here. No? OK, not today. This is the log level. Now you can look at the stream. Once again, you have everything, but you can again say, oops, container image name equals, and then Java logging, for example, is my container name. And if you run that, you can see these are just the log messages from this container. And then you could say stream live. If I run my container again, then give it a second or so, because here the timestamp will change in a moment when it streams in the log file. And the nice thing is you can filter down on a specific container, for example. You could also highlight. So for example, we can say I'm just interested in the errors. And you can see now we have gotten the log files. And when you scroll up here, wherever error is, here you can see now we have been highlighting error. You can also see here how many log events have you collected and where is your kind of like word that you have been highlighting. So here is one entry that is being highlighted. And you can just filter down on those and live scroll on those. So since we're getting short on time, this is nice and works. It's just a bit more complex because of Docker. And then people want to orchestrate normally with Kubernetes. Whether you run FileBeat on Kubernetes, normally a daemon set, you have one per host. We also have the configurations there. What you basically do is you say, OK, this is running on Kubernetes, and then it will figure out where are the logs by default, and will pick them up as configured down here. You can get the Docker metadata. So for example, the metadata here, you see we have a pod, we have a namespace. We can enrich all of that to see what we actually have, and you can filter down on those as well. That is not so important. We can skip those parts as well. So even hotter, but even a bit more complex. But we have the configurations online for that one. So to wrap up, if you want to try that out, you can just pull the code, do a Docker Compose up. It will run the entire demo for you, and you're done. So this is pretty easy to do. And it has all the configurations and everything in there. What we've basically discussed is parsing, if you have to. We would probably avoid sending, because you might lose the most important log messages when something is going wrong. Structure is what you can do to make your life easier, to write out logs to JSON directly, or maybe CSV if you have to. Containerize is mostly getting metadata from Docker, and orchestrate would be metadata from Kubernetes. With that, I think we have 1 minute left. If you want stickers, by the way, I have a couple of stickers over there. So if you want to stick them on your kids, your laptops, whatever, grab stickers. Any quick questions? Otherwise, I'm also around afterwards. Questions.
Question.
Nobody dares to ask. Well, if you have any, come find me afterwards. I'm happy to help you out. Thanks a lot.
Thank you.